Hi everyone, and thanks for tuning in again. I'm Alfredo, and today I want to talk to you about functional programming. As most of you may know, functional programming is a programming paradigm which contrasts, but it doesn't eclipse, object-oriented programming, and it has a lot of differences to it. Functional programming is mostly based on the notion that we can leverage some of the principles of mathematics, particularly of the lambda calculus, to write our software better. But what is functional programming about, concretely? Well, it is programming software the very same way that you already know, coding and following logic. But it provides a set of tenets that it invites programmers to follow strictly. For functional languages, for most intents and purposes, constants, variables, and functions are basically the same. Functions. For example, you could think of a constant or a value as just as an identity function, where the function is a first-class citizen. Pure functions, that is, which means a function that takes immutable input and produces immutable output. So at no point in the equation there share immutable state. Next, to prefer composition, to create complex behaviors in your software, composition of pure functions, that is. Every function carries a closure, which is all of its local state, and this closure it's not shared at any moment with any other functions running in your software. And finally, preferring the use of recursion over iteration and the implementation of lazy evaluation in your software. The second of which is the principle that you shouldn't compute a value out of a function unless if the program truly demands it. Now, most, if not all, of the mainstream, readily available commercial programming languages in the world of 2020 either have functional programming features or allow both models to coexist. And this is kind of the consensus right now, where your data-intensive operations can be very easily coded in a functional style and the business logic can be objective. The main advantages of functional programming are, firstly, that it enables a declarative coding style for your developers. That is, it enables developers to write software without having to worry about the smallest detail in every implementation and without falling into a lot of boilerplate code, which in turn leads to developer productivity, shipping better, more concise code with less surface area, less bug prone, and with less defects around all. This in turn leads to developer productivity, shipping software faster, and just basically a really good experience enjoying the joy of programming, which is ever so important. So now, let's take a look at that example, and let's jump on the computer. Alright, so what do I mean, first of all, when I mention that functional programming is about doing sort of mathematics with code? Well, it's very simple. For example, if you have something like, let's pretend that we're doing algebra, or well, rather, let's pretend that we're writing a piece of software, your common software, right? Let's think that we already have a variable called x, and we are incrementing it by 1. So, is this a mathematically sound expression? It actually isn't, because if you actually balance this equation as if it was algebra, placing the terms on the left-hand side of the equation, you have x minus x equals 1, and this doesn't make mathematical sense. So it means that this programming language that we're talking about uses mathematical symbols without the same kind of connotation. It assumes that x is a state that you will maintain over time, like a little place, like a little locker where you deposit data and you read data out of, and you change its contents over time. And instead of that, functional programming proposes that we shouldn't have to do that with computers anymore. Maybe back in the 70s, back in the 60s, when memory was a lot scarcer, and when we didn't have the same kind of programming languages and the same kind of theory. A little bit better functional form, will be something as, for example, if x is y, x is 1, and y is x plus 1, y is our increment. Okay, so for the second example, let's try to solve for x and y to see whether it actually sticks to proper mathematical form. So we can solve for x on the second equation, x equals y minus 1, and then substitute on the original one, y minus 1 equals 1, which in turn tells us that y equals 2. And substituting on the second equation, you have 2 equals x plus 1, which necessarily entails that x is 1. So we get the behavior that we are expecting, which is an increment, but we stick to proper mathematical form. And this has a lot of advantages. If you notice, at no point we share the state. This matters particularly when you have concerns of concurrency, on which I will elaborate in a bit. But carrying on, let's do a little bit of an exercise. Let's do a little bit of code here to show you proper functional programming. Now I'm gonna open up Pry, because Ruby is inherently object-oriented, but it has tons of functional programming features, and I really like it. There's a lot of purer functional programming languages like Scala or Clojure, and those are definitely worth your time, but I would like to stick with Ruby for now, for this experiment. Now, in Ruby, well, in functional programming, functions are so common that it is fine to omit their name, to just call them an anonymous function. And every functional language has a way to either name your function, to just assign it to a variable, or you can just type lambdas, which are anonymous function. Lambda, as in the Greek lambda, is used just as a stand-in for the name of the function. So in Ruby, we have this construct, and the construct is, for example, if we want to define an anonymous function that adds two numbers, incredibly simple stuff, we can just do lambda of x and y. We can do this kind of notation rather, x and y. We return x plus y, simple stuff. In Ruby, the last statement in a block of code is the implicit return. So this is going to implicitly return x plus y. So if once you have an object of this type, of a lambda, then you call it with .call. So you can do .call and then 2, 3, and that's going to return 5. So all is well. Now, this notation can be simplified. You can just do add dot and then pass it like that, 2, 3. Why does that happen? Ruby has a lot of aliases just for developer convenience to make them typeless characters. So keep that in mind. Both of these notations are equal, and the lambda notation can also be abbreviated. The lambda that we define we can define as a function of xy, then stabby lambda of xy, and then we just pass the same code. Add dot of 2, 3, and it's going to return the same result. So stabby lambda, like line 4, and explicit lambda, those are equivalent notation. So all of this is cool and all, but well, let's just start trying to think about something more complex, because again, remember algebra, how you had f of x and then you could do f of g of x, which was a function composition? In functional programming, you literally do that all day long, and that's how you achieve big and mighty programs, like the big and mighty software that all of us like and that all of us need. So how do we do this? Well, let's define a function. I'm sort of thinking that what if we type a simulator of a techie simulator? So let's try something like well, what do techies like? Well, they love to have big brain opinions of things. So let's call it big brain opinion, and then let's make it a stabby lambda of a certain string, And yeah, what's techies love technical jargons. They love to call things stateless and race condition. And %W is a helper in Ruby that you can use to specify an array of strings, but turns out that if you actually want to create a string with a space inside, because it just assumes that everything separated by a space inside of the %W is a string of its own. And if you want to create a space, you actually have to escape it, which is pretty cool. Well, what else? They like idempotency. They like transient things. What other kind of stuff do techies like to talk about? Oh, they like to talk about orthogonality. And yeah, let's go with this sample for now. So in Ruby, there's a helper method in enumerables.sample, which just produces a random sample out of that. If somebody has a big brain opinion on something, let's just concat this to the concat to. Well, I want a space for this, so I'm gonna use interpolation, which some people are like hesitant to use interpolation, but I mean, I like it enough. So now we have a lambda for big brain, big intelligent boy, which opinion on things. And what if we had what do techies talk about? They love keto, so race condition keto, or an orthogonal keto and a stateless keto. Okay, so things are looking good. Let's try to. But what else? What else do techies like? Techies love to be loud and assertive and to be confident about things. So yeah, maybe let's try to create a function to reflect this. Loud and stabby lambda of I and just I dot upcase. Bear in mind, all of these functions never share state. In Ruby, dot upcase, it will literally produce a state in another section in memory. It will not share the original contents or the original characters that you pass to upcase. And literally in Ruby, you can do upcase with an exclamation point to do it in place. But normally, unless you have a very good reason, normally it should be transparent to use this. So loud like that. And well, so now that I have these two functions, I can aggregate them. Now I can be a very loud and very big-brained boy, big-brain opinion on keto, because I'm a techie and I love keto and I have to tell people that I do keto. Oh, and we need the operator here. Stateless keto now we are assertive about it. Stateless. It's keto, but it's stateless, bro. It's idempotent. It's transient. It's stateless. Okay, so that's looking good. So we have loud and we have big brain. What else do we like? Techies love to exclaim. So let's get some freaking exclamation points on this. Exclaim equals stabby lambda of I, and then just return I dot concat and exclamation point. So now it's following the same aggregation that we have. We can ask somebody to, well, we have a loud big brain opinion of keto, and now we can exclaim it. Exclaim a loud big boy opinion of keto. You know that. Orthogonal keto. Did you notice that now it's getting a concatenation at the end? So now, there you go. So one of these days, this guy is going to be able to take over your stand-up, you know? So, well, another thing that I think that they really love is to speak succinctly and to drop bombs on whatever they're talking about, to try to gain leverage or to try to disparage other people. So let's call it, yeah, it's a really confident kind of talking. So let's do stabby lambda of I and then return, well, actually, and then just interpolate the I. All right. So now that we have all of this, we can confidently exclaim loudly that we love keto. Oh, well, actually, stateless keto. And it gets uppercase. So do you see what I mean? So I think that it sort of lends itself to a really natural pattern. We're just creating tiny bits of definition, of logic, and we're just placing them together in a really natural way. But if you have a function, you can use the output of that and partially apply an input which is sort of preloaded to create a new function. In functional programming, this is called currying, out of Haskell Curry, one of the main contributors to the lambda calculus, and in honor of whom the Haskell programming language is named after. So we can do sometimes techies really like to overextend their confidence and make it into arrogance. So arrogantly equals stabi lambda or of I, and then I'm gonna call confidently of I and concat, and let's concat to this some disparaging declaration like yeah, I'm just gonna laugh at you, code reviewer here, bro. So alright, and arrogantly of that, if Ruby has a construct on lambdas called currying, and it's a way to preload one of the arguments that's gonna go in that function. So we could call insult equals arrogantly.curry of Alfredo. And now, well, actually, Alfredo. So, kind of cool, right? And what happens in tech is that sometimes techies like to really get into arguments. Oh, they love to prove how smart and how cool they are. So sometimes they like to well, remember that we were confidently exclaiming that we had a big great opinion? What if we have a very arrogant opinion on things? Arrogantly exclaim, oh, we're actually race condition keto. And if you notice, there were no sizable code changes. We didn't have to track back and modify the logic, and the logic is sort of adapting to our brains rather than having our brains have to adapt to the logic. I sort of had this idea, what if we have an alias for one of the functions? So exclaim, so for intensity, and arrogantly exclaim, very arrogantly exclaim that you have a really strong opinion on keto. So notice that how there's a difference here. There's an exclamation point now, and maybe sometimes you could like, what if we define a function like this? Really? And this is just gonna call 3 times very. So very of I. Maybe we can change our logic here to really arrogantly exclaim out loud how much we fucking love keto, man. Fi. You may notice that lambdas get created and they don't validate that the code is good until when they actually run. This is lazy evaluation. So, and maybe we can make it really, really arrogantly stateless keto, and notice how there's more of this. So, but carrying on, let's bring it home. Maybe if you want to define what a tech bro is, maybe you could say that a cool tech bro is somebody who, and a tech bro likes to really confidently exclaim loudly that they have a big boy opinion on the blockchain. Because everybody has an opinion on the blockchain somehow. Let's take a look at this. I didn't use the right operator here, and I need to change it to I. All right. Oh, race condition blockchain, orthogonal blockchain, idempotent blockchain, orthogonal blockchain, and more until you get promoted to SD3. That's how things get done. How you like them, apples? No class hierarchy, no namespaces, no freaking bloat and over engineering for the sake of over engineering, and we're getting some really cool stuff. But of course, more seriously though, there's a lot of other applications of functional programming in Ruby. Something which, of course, a lot of you may be familiar with is mapping and reducing, which are methods that you can use on iterables to do transformations by passing a function or a block of code rather, because in Ruby every function is a block of code, but not every block of code can be a function, what is known as a proc, right? But maybe that's something that we will cover in more depth in some other location. But for example, in Ruby, you can do from 0 to 100, and you can just do that sum, and that's an alias for a very complex map reduce series of invocations that knows how to treat everything inside of the range as a number and sum it all together. So this is equivalent indeed to the readus and readus to underscore and I and return underscore plus I, where there's this kind of notion in a lot of functional methods in Ruby where there's two parameters and one of them is sort of an accumulator where you make successive calls to the same function by accumulating in one of the parameters. So see, it's the same result. This readus method, you just pass a symbol to plus. What if you wanted to get a list of all of the squares from the numbers from 0 to 100, but in Ruby it turns out that you can just do an invocation to map and you can just pass a function or a block of code, as I mentioned a bit ago, where I times I. Or for example, what if you want to do a list of twice every number from 0 to 100? So this is also perfectly possible. Let's try to do something with names. Maybe we can define a list like this, and we can call that reduce on this, similar to the shortcut that we had a bit ago, and it will take every element inside of the iterable and it would just map it to the reduction of them, which is a concatenation since they are strings. Ruby has a lot of really cool, really fluent methods that allow you to do really sophisticated things with very little effort. For example, that's select, and select takes a function which you pass to it again, and you can just do select I dot starts with. Oh, it's start with. You may have noticed that I omitted the parenthesis there, because in Ruby it is possible to omit the parentheses in some invocations. So for example, this and this are absolutely the same. But what if we want something like .a, right? So there you go. So it just slices through the collection of data and it just gets me the elements of the list which I actually need. We can, instead of this, we can evaluate for I.contains contains A. I think it's that include then. So everything that has an include, maybe we can modify it so it just includes E, or I think that Albuquerque, it's a really unique term out of that list. So if we filter for include Q, do you think that it's going to return Albuquerque only? I think that it will. So there we go. So really, really flexible. And again, ponder this. How long will it take you to code this in Java? Like from scratch? And it will take you a lot of review and a lot of processes and such interface and such parser and such thing. And I mean, and you don't need that. Like, you don't need a lot of that. And even Java themselves know, because modern Java has functional programming constructs. And the cool thing again is that this enables a lot of really agile operations on things, which make your life a lot easier. For example, what if I have how many names do we have here? We have 4 names. So you know what? Let's actually go back at Albuquerque and let's define at least let's call it names. What is names? Names is that. So from 0 to the names dot length. Then zip is a utility method that you can use in Ruby to sort of produce an association. I'm gonna do -1. Okay, and now we can do dash to h, and there we go. We have a hash map, and it's so freaking beautiful. Hash maps have .map, and you can actually map or reduce to your heart's content. Where, by the way, map is generally agreed to be an indication of a transformation on the elements of data of an iterable, and a reduction is an operation that is going to encapsulate everything in that transformation and it's just going to mash it into something. So you can map to KB, and well, what if you want only cases where K is less than 2? This is perfectly possible. Oh well, it mapped it to that. Map to, well, you can do select actually, and there you go. What if you use 1.1, and there you go. I'm thinking that's everything for now. This is good for a primer on functional programming, but I really invite everyone to get into this. Believe me, you have no idea how convenient and how fun it is to program this way, and how many doors it opens to you, because there's a lot of interest out there on the subject of big data, as in how to optimize data processing so it is highly concurrent. And you can do that literally with programming languages like this, which have constructs for mapping and reducing, where you can define the transformations of data just with functions. Like all of the big data task runners like Spark or all of those come from functional programming and the facilities that it gives to you. You get to do concurrent programming faster and better because you don't share state. You don't have to worry about heap corruption. You don't have to worry about thread lock. You don't have to worry about managing concurrency manually, which is a pain and which can be horrible to debug. The functional programming paradigm is everywhere these days. So I think that no matter your persuasion or no matter what you need to do with programming, you're gonna find something cool if you dive into it. So I think this is everything for now. Thank you so much for watching as always, and I hope that all of you are staying safe. Have a great day, and I'll see you around in the next video.